Hey everybody, Math Day 87 with Grandma. Here's our poem riddle for the day. Holiday spirit. A simple phrase that some believe, better to give than to receive. The more we share and less we take, a better world is what we make. How many presents do you see? Imagine where a gift could be. Find the sum including these, then subtract them if you please. Well, here's a full row. 1, 2, 3, 4, 5. So if we imagine they were all full, it would be counting by fives. 5, 10, 15. Minus 1 is 14. Minus 2 is 13. 1, 2, 3. I could have counted by threes. 3, 6, 9, 12, 15. I still would have subtracted 2 presents and gotten 13. Because 3 times 5 is 15. Book number 4 in our adventures with Sir Cumference by Cindy Neuschwander and illustrated by Wayne Gehan. This one is Sir Cumference and the Sword in the Cone. The famous tale of King Arthur is The Sword in the Stone. The Sword in the Cone. Meaning new character. One fine morning, Sir Cumference, Lady Di of Amateur, and their son Radius were eating breakfast in King Arthur's castle. Suddenly the door flew open and a young knight ran into the room. It was Vertex, Radius's best friend. I found out why King Arthur has called us all here, Vertex exclaimed. The king wants to choose an heir, Vertex explained. 5 knights are competing for the honor, and I'm one of them. You'd make a fine king, Sir Cumference said. That's right, agreed Radius. You helped the king make peace with the Euclideans last year. Yes, but now I have to solve this puzzle on this parchment, Vertex said. The king has hidden his sword, Excalibur. The knight who finds it will be the next king. Vertex unrolled the parchment. This is the only clue the king gave us. Form the solids and find their places. How many edges, points, and faces? The shape that makes 2 will pass the test, but one that does not must be your quest. 3 times as tall as its base is wide, the true king's future lies inside. Look at these strange drawings, Lady Di remarked. They look like wooden tabletops. Let's go ask the carpenters, suggested Radius. They know a lot about building tables. Vertex and Radius ran down to the courtyard. They saw other knights trying to find Excalibur. One knight was carving solid shapes out of wood. Another knight was counting the edges of each stone in the castle. A third knight was inspecting the points of several swords. The last knight was looking through school books for a text with the number 2. I know a shortcut, said Radius. He led Vertex into a tunnel. This would take them under the courtyard into the carpenter's workshop. The tunnel was dimly lit, and scratching and squeaking came from the dark shadows. When they got to the workshop, Vertex showed the carpenters, Geo and Sim of Mitri, the drawings of the parchment. You know what these are, he asked. Oh, yes, answered Geo. Those are diagrams showing solid shapes flattened out. So if you look at this one, a bottom, a side, a bottom, a side, a top, and a bottom. If I would fold it all together, I could make a rectangular prism. Vertex and Radius cut and folded the shapes. The parchment says the shapes that make 2 will pass the test, Vertex said. This cube has 6 square sides or faces and 8 corner points and 12 edges. Where the faces come together, that's how do you get a 2 from that? Look at the pyramid. It has 5 faces, 5 points, and 8 edges. I don't see a 2 anywhere. Maybe we have to add the numbers of faces and the number of points, said Vertex. If we add the pyramid's faces and points, we get 10. 10 minus the 8 edges is 2. Does it work for the cube too? The cube's 6 faces plus its 8 points is 14. 14 minus the 12 edges is 2. I think you've got it, Vertex. Oh, they've made a chart. Vertex and Radius finished making the shapes. There were cubes, pyramids, rectangular prisms, triangular prisms, cylinders, and cones. Vertex counted the faces, corners, points, and edges of each shape, and he added the number of faces and points, then subtracted the number of edges. The answer was 2 each time, except for the cylinder and the cone. Vertex unrolled the parchment and read again. The shape that makes 2 will pass the test. The one that does not must be your quest. The cylinder doesn't have any points, and the cone doesn't have any straight edges. They can't make 2 and pass the test. Our next clue must be a cylinder or a cone, he announced. Look at this, said Radius. I made a model of the castle from the shapes. Here is the pyramid roof on top of the rectangular tower. The other towers are the cylinders with their cone-shaped roofs. Vertex looked at the model. Let's search for Excalibur in the round towers, since they are built in the shapes of cones and cylinders. Vertex and Radius climbed up and down the spiral staircases in each round tower. They looked under every trapdoor, in every suit of armor, and behind every tapestry, but there was no sign of Excalibur. Let's search from above, Vertex said, and they went up to the roof. Vertex had a commanding view of the castle courtyard. Look at the stones in the path, he said. Each of those round paving stones could be the bottom of a cone or a cylinder. That path is the same direction as the tunnel we went through. Vertex and Radius returned to the tunnel. Sharp points jutted down from the ceiling. These points could be the tips of cones, Radius said. We need to dig them up, said Vertex. Vertex and Radius waited until nightfall when the courtyard was empty. Vertex remembered the words of the parchment. 3 times as tall as the base is wide. The true king's future lies inside. If the base of the cone is the circular bottom, we need to measure the width of the paving stones. Vertex measured one of them. This cone is 18 inches across the base, so it must have a height of 42 inches to be 3 times as tall, Radius replied. Vertex and Radius dug up the cone. It was 47 inches high. Oh no, it's more than 3 times as tall. Let's try another one, suggested Vertex. He and Radius dug all night. They unearthed and measured many cones, but none of them was right. Some were too tall, while others were too short. They still had many cones to go when the full moon set and the day began to dawn. We'll never finish, groaned Radius. We've looked for clues in the tunnel and dug up lots of cones. What else could we look? We've looked over the cones, under the cones, and on the cones. But what if Excalibur is hidden inside a cone, suggested Vertex. Are any of them big enough? Excalibur is a sword, so it has to be about 48 inches long, about the same length as this shovel. Vertex said, Radius, you go back down into the tunnel. Soon Vertex heard Radius' voice. I'm in the tunnel. What am I looking for? Vertex placed the shovel in the nearest hole. Can you see any cones that are as long as a shovel? I see 4 cones that are about the same length, Radius answered. Excalibur could be hidden inside any one of those cones. But the cone we seek must be 3 times as tall as the base is wide. So this one is 24, this one's 36, this one's 21, This one's 17. 48 inches divided by 3 is 16 inches, said Vertex. He measured the bases of the 4 cones. All were more than 16, but the last one was close. As the sun peeped over the edge, Vertex started to dig. Radius ran back to the courtyard. Vertex heaved and tugged on the stone. Finally, he pulled out the large cone. Vertex measured it. It was exactly 51 inches high, 3 times the 17 inches on the base. Vertex pried off the base of the cone and pulled out the gleaming sword. "Excalibur is found!" he exclaimed. As Vertex held the sword aloft, everyone in the castle came running. King Arthur said, "You have solved my puzzle, Sir Vertex. Tell us how you used your wit and will to find Excalibur." Vertex bowed low. "Sire," he said, "I folded each of the diagrams on the parchment into a solid shape. Then for each solid I added the number of faces to the number of points and subtracted the number of edges. The answer was always 2 until I got the cylinder and cone. So Radius and I searched the parts of the castle shaped like cones and cylinders. We found these cones buried in the courtyard. One of them was 3 times as tall as the base was wide, and Excalibur was inside." Vertex knelt and held out the sword. King Arthur said, "Sir Vertex, you have used your intelligence to earn the greatest honor I can bestow." The king took Excalibur and tapped Vertex on each shoulder. "I.W. Prince Vertex, when I can no longer rule, you shall be king. Rise now and greet your subjects. In your hands the future is in solid shape." The crowd cheered. Vertex said, "I want to thank Sir Cumference, Lady Di of Amateur and Radius. They helped me measure up to the challenge. I'm sure they will be my advisors when I'm king." Vertex eventually did become a wise and thoughtful king, known to his people as Vertex the Lion-Hearted. To this day, the point of the heart of the 2 or more lines is called a vertex. There really is a mathematical 2's test for geometric solids. It's called Euler's law. A Swiss mathematician named Leonhard Euler proved in 1751 that if you add the number of faces on a geometric solid to the number of its vertices, and then subtract the number of the edges, the answer will always be 2. It works for any polyhedron, straight-sided shape. Sir Cumference and the sword and the cone.